Welcome to the third tutorial from Simulation and Prototyping at Lawrence Technological University. This third tutorial is going to look at the aggregation of a number of parts as a way to create a form. And so what we're going to do is create a path, and then we're going to map a series of objects to that path as a way to create volume and form from that. We can see some examples on the screen on the right, just in the way that those are built up. And let's look just briefly at some of the things that are happening here, or some of the control that we have. And so we can change the path that we're going to work with as these kind of variables or these parameters. We can change where this is located vertically. We can also change the slope of the helix that these are mapped to, basically how dense we want to pack this. And then we're also changing the kind of angle in the way that these individual parts are mapped onto those points in space. And we'll use a couple of new commands, and hopefully with this tutorial, we can reinforce a little bit with data structures, and we're going to have to talk about how to manipulate some data to get it to do exactly what we want, and reinforcing some of the other issues that we've already been working with in the first couple of tutorials. So this is basically something that we'll build. I'm going to start a new file now, and I will use large objects feet, and I'm going to start a new grasshopper file. So we'll start fresh with these. And so what I want to do is I want to start with basically the only geometry that we need in Rhino is a point. It's easy enough. We'd have to construct X, Y, and Z components in Grasshopper if we wanted to do without. But in this case, I'll just start with one point. I'm going to set mine to 0. And I'm going to set it to 0 so that I know exactly where the origin is, but I actually want to then move it off of the origin, just so that when I create a plane, I'm specific about the location of that plane and that nothing's defaulting to the origin, just so that I can be in control of that. I'm going to change this to perspective view and locate my point in space. So because I have a point in Rhino, let's create a component that's a container for that point in Grasshopper. We can set that one point, and now we have that. And so what I want to do is start with that point. I want to create a circle and just use that circle as a reference for us, so that as we start to build other things, we can see that again as a kind of frame of reference. And so let's see, I want to make a circle. I know that that's the case. And so how about I start with circle? And as is just kind of general good practice for us, then we can see what the inputs are. So we're going to need a plane. Let's create this on the XY plane. And we can see that plane and now the circle are both defaulting to the origin. This is why I wanted to move that off. So I'm going to set the point to be the origin for the plane. And then I'm going to set the XY plane to be the plane for the circle. So we have both of those. And now let's set a radius for our circle. And I think 10 is probably a good value. So I'm going to do 1 is less than 10 is less than 25. This just gives us a little bit of a range. And so now we have our circle. I'm going to leave the plane and the circle and the point. I'm going to leave everything on for now. I might just rename this and call this radius circle. And again, as the kind of frame of reference, as the way that we were working in the first tutorial, I want to move a point to the 12 o'clock position on the circle. So I'll do that with a move. And that geometry that I want to move is the point. So I can do that. And I want to, referencing our XYZ axis, I want to do this in the Y direction. So I'll use a unit Y, and that'll be tied to the motion. And I also know that I want this to sit on the circle, and so that'll be the same. The unit Y will be the same as our radius. So now we have our center point, our circle, and our point on the edge of the circle at the 12 o'clock position. So this is good. This gives us our starting point. Now what I want to do is rotate a circle as a way to build a helix. And so now we have the rotation. The geometry that we want to rotate is our point. The angle, let's remember to set this to be degrees. And our plane is going to be our same XY plane. So we can pull this one over. And so we'll begin to manipulate the angle. And we'll do this, let's start by doing this in a couple of ways. So first of all, we want to not, so the way that we worked with our first tutorials, we added a slider, which added 1 point. In this case, because I want to build a helix out of a larger set of points or a list of points, I'm going to start with a range. And this range, I want to work from 0 to 360. So let's create a range. And we know that with our range, we have to construct a domain. So we'll construct domain. And our domain start is going to be 0. Our domain end, let's set this to be 360. And as I do this, and as we manipulate some of the, we're going to play with or manipulate the data as it relates to this range, I want to create a panel, which you'll see in a few minutes will be a whole set of panels, just so that we can track the evolution of our data as we build it to send it to our rotation. And so let's set our number of steps as well. So right now our range, the default steps is 10, and it's going, we can see it's going from 0 to 360. That's what we want. Let's set our steps with a slider. Let's say 1 is less than 4 is less than 10. And I actually want to have a small number of steps within here. 3 or 4 is good, just because we're going to, you'll see in a second, we're going to duplicate this data. So we can see from our panel, we get 0, 90, 180, 270, and 360. We'll come back to this in a second, because I already know from having done this before that we're going to have a little bit of a problem. I know I keep doing with my hands clockwise. This actually is working counterclockwise today. But 0 and 360 are in the same location. And so this is going to create a little bit of an issue for us, but bear with me because I want to show you how to fix that. So now we've got these points. And so let's take this range and we'll plug it in. And now we can see we get 4, what look like 4 points on our circle. It's actually 5 points, because remember it's 0, 90, 180, 270, and 360. But for now, this is okay. We'll keep that as it is. And now, in order to start building our helix, what I want to do is to move these in the Z direction. And so we'll move out of the flat plane of the plan of the XY, and let's move these points up, and we'll move them up in the Z. So we'll start with a move. The geometry is going to be the geometry of the rotation. We can see they've already moved up, but by a default, So we want this to be in the Z. So we'll say unit Z. And then let's add to this. Let's see, maybe we'll just give it a slider for now. Well, if we give it a slider, here's the thing. If we give it a slider, let's see what happens actually. 0 less than 3 less than 10. Okay, so they're all moving up the same amount. And what we're doing is we're only giving one value to this move, but that's being coupled with the range that's coming from the rotation. And so what I want to do now is to actually build this. And in the same way that we used range to set our range from 0 to 360, I actually want to use series for this, because I don't want to set it between two values. I want to allow it to just keep stepping up. And so what we'll do is we'll replace this slider with a series. And I think in class we talked briefly about the difference between range and series. And so we'll see those play out again, and hopefully this will help reinforce it. I know it's a kind of abstract concept until we start manipulating these things. So it's okay if you're not quite getting it yet. Hopefully you'll get a sense for it today. Okay, so with our series, we can see our range has two inputs, domain and the number of steps. With our series, we're going to set a slider for where it starts. Let's say 0 is less than 10. Because it can start at 0, and that's fine. Our step, I think our step is going to be relatively small, but let's say 0 is less than 1, is less than 5. We'll set that for our steps. And then let's do our count. And so just for, let's do this. Let's pull our number slider that we are feeding to our range. It seems to make sense. It's not actually going to work exactly, but I want to do this as a way to show you. Let's pull the number slider, pull the value from our number slider over here into our count. Here I'm going to copy our panel, and so we can see what we get out of the series. And so we have a little bit of a problem, not a big problem, but I think it can be confusing when Rhino sometimes counts 0, sometimes doesn't count 0. So in the case of the range, when we plug in 4 to the number of steps, it's 4 steps in addition to 0. In series, when we plug in 4, it's 4 total. And so these two are off by a little bit. We can easily fix that. So let's watch and see what happens when we take our series and we plug it into the unit Z value. We can get rid of this slider. And so now it looks like these are increasing. And what we ultimately want to have is to have a curve that begins to trace these. So this is called an interpolate points, or an interpolated curve. So we'll select this. It's a nice curve. It gives us a lot of options. Basically, all we have to do is plug in points to it. And we get a curve drawn through those points. And so we can see it's starting at 1. It goes up a little bit, up a little bit, up a little bit. And actually what's happening here is that because our number of points is driven by the domain and driven by the range, and our vertical, the way that we're elevating those points in Z, is driven by this series, we can see that the last 2 points are actually the same. It's just duplicating. It's doing 0, 1, 2, and 3. And so this is 0, 1, 2, 3, and 3. And so there's an easy way to fix this for now, is let's just add an addition. we can just add one more, and we can take our number slider from here, plug it into A. Let's add 1. And plug this into the count. There, now we saw that that last point was elevated up. So that's nice. These are moving up in a kind of helix. And so if we increase these, we can see that the number of points are increasing. We can actually hide our rotation. We can hide our move, our first move. And so we're just left with these points over here. So you might think, and I made this mistake, it's like, okay, I want this helix to move up more. What if I increase the number of points on this first slider? Remember, oh, and there it's moving up. But if I zoom out, it's still only 1 revolution as a helix, and we want it to be able to go up. We want it to be able to revolve multiple times. And so increasing this range is still only going from 0 to 360. And so all we're doing is adding more points, and it's lifting up because each of those points, again, because of the series, is adding that many more points so that it gets elevated. So if we just wanted to do 1 rotation, this would work. But we actually want to have multiple rotations. So I'm going to turn this back down to about 3 or 4. And we can see now we're starting at 0, we're moving up, that's working. But we also have the problem that these 2 points are on top of one another. And we'll see what happens in a second as we do this. So we want to create multiple revolutions. We can do this easily by duplicating. So let me create a little more room within here. And we want to duplicate data. Let me copy this panel as well. We'll plug this in and we'll see what we get. Right now, nothing. The data that we want to pull in is from our range. And so we can see that the number is set to 2. And what's happening is that this is just duplicating from our range over here, which goes from 0 to 360. This goes from 0 to 360 and 0 to 360. So we can add, again, I like to have my variables off to the left. But why don't I add 1 is less than 3 is less than 10. And these will be our number of revolutions. And so we can name these others. This will be, let's say, circle division. And this will be helix rotations. And those helix rotations, we can see, let's see, I plug that into order. I should have plugged that into number. So now we can see that we have 3 duplications of this. As we increase this, it will give us that many duplications of our data. So this is 6 times that it's going from 0 to 360, 0 to 360, 0 to 360. So let's see what happens when we take this data and plug it into our rotation. Let's see, something didn't work because we're not getting our interpolate curve. Let me hide our interpolate curve for a second. One of the problems that we have here is that our heights are only 1, 2, 3, 4. And so what's happening then is probably, we can see those top set of points are not being moved up in the Z direction because we don't have enough values within this list to be coupled with the values in this list, right? This list is rotating. This list is elevating. And we can do this with our series. So let's change one thing with this. Our count earlier worked when we weren't duplicating our data. And we were just adding 1 to what our count was over here. That's not going to work anymore. So let's do this. And we can see as we deleted that by restricting that count, this changed and this changed what's happening here. There's a really useful tool called list length. So if we type list length is up here at the top. List length will take information from a list and simply tell us, here I'll copy this panel, plug it in here. The output of this is just to tell us how long a list is. And so this list is 30 items long, again, because we start at 0. And then all it tells us is 30. And so for the series, we can plug in this list length. And now we can see those points moving. So what we've done is we've created series doesn't have an end. Range has an end. Range is set between its domain, its min and its max, whereas range is set between the domain, the min and the max. Series just keeps adding at a certain interval based on our maximum count. So in this case, we can match our data for the move of the Z based on the length of the list that we duplicated before. And so we're getting 30. This then creates 30 items here. And we're feeding that to our move. And then here's our interpolate curve. Now it kind of looks like a helix, but there's a bit of a problem. And this comes back to the issue that I told you before, is that 0 and 360 are in the same place. So watch what's happening with this. Starting at 0, 90, 180, 270, 360, and 0. And so these two are right on top of one another. So this curve is interpolating those points exactly in the order that we're giving them, because we're elevating each one of those a certain increment. The problem is that 360 and 0 are right on top of one another. So this is also something that we're going to fix with our list and with the data. So you can see we're doing a lot of work on the lists that we have as a way to drive the geometry. And so the last tool that we're going to use to fix that is an item that's called cull. And cull just means to remove something from a list. And so and you can play with some of these things up in the top left under sets, under lists. There's a whole bunch of different tools for managing lists. Under sequence, we can see that there's a few that start with cull. So what we want to do is just simply cull a specific number, and it's called cull index. We're going to use this here. The list that we're going to cull is our very first list, because again, we're rotating. We're duplicating 0 to 360, 0 to 360, 0 to 360. We don't want to duplicate the 0 item or the 360 item. In this case, what we'll do is we'll cull this list, and I'll create another panel just so we can track the evolution of this data as we go through. We need to give it what index we want to pull out. Well, rather than give it a specific number, because this could change if we change anything over here, let's give it our circle division in terms of the index, the indices, the index that we want to remove. And what's nice about this, we can see our first in our range, 0 to 360, our next list, 0 to 270, and then we haven't plugged this in yet. When we start duplicating this, when we duplicate this data, this will go 0 to 270, 0 to 270, 0 to 270. So already off to the side, we can see we get a nice spring, our nice helix. So we've eliminated that duplicate item within our list. And so hopefully you can just understand that with the panels and see simple list and what's there. As we increase to 5, 6, 8 to 9, we're removing the 9th item is 360. And we're just simply removing the 9th item. When those get duplicated, 360 is not duplicated. We can delete these panels. They're just simply an output of that. But we can also leave them there. They're not hurting anyone. And if you get confused, you can come back and you can take a look at that. So at this point, now we've got a nice helix. We can control back at our series where this starts. So we can elevate the whole thing. We can change how tall it is, how much each point is elevated. And given that there's a big range for us between 0 and 1, given the number of points, I'm going to revise this slider and move it from being an integer to a real. And I'm going to change the maximum value from 5 to 2. So now we can kind of lower this down and we can get a lot more density when we start copying our objects and placing them along there. So we've got our helix. And actually for this, and there's probably ways that we could use those points or not use those points, but I think those points are enough. And eventually we could probably, in terms of dividing the circle, we can revise this, maybe 6 as a maximum. We're getting a pretty good circle with those 6 points because of the way that it's interpolating those points. 3 gets a little wonky. 4 begins to approximate that circle. But as we get to 5 or 6, it's a pretty good helix. So 6 seems fine. We don't need more points than that as a way to get our curve. So what I'm going to do is then, I don't need these points, just simply need the curve. And at this point, maybe I don't need the circle. I was going to say I don't need the plane or the center point, but let's keep those because they're going to be a frame of reference for us in a minute. So this is good. You can play a little bit with some of your sliders and get your helix to change. We can also change the radius of our circle. And that's all off of the center point. That looked a little strange when I did that a second ago, but we can see it's moving in and out based on the circle. There's nothing magic about any of those dimensions that we've given it. So you can manipulate some of those things and see what happens.